everybody. This is Mr. Munson, and we're going to be looking at angles and polygons, part 2, regular polygons. Okay, so let's just step back to last lesson, and we're just simply looking at polygons here. These are not necessarily regular polygons. Matter of fact, once we do the calculations today, we'll know for sure that these are not regular polygons because of these interior angle measurements. But we want to find x, and so as soon as I see that x, I know I need to write an equation. So here's the concept I want you to understand. I want you to understand that those three angles, which go together and form that pizza, each one of those three angles actually add up to be 360 degrees. So once we realize that concept, writing an equation is quite easy. Okay, and so all three angles add up to 360. Now it's just a matter of using algebra to get down there to the final conclusion of what x is. Now this is a very similar looking problem. It's the same kind of shapes, but in this case, they're telling us this thing's a regular polygon. So as they tell me that, I'm going to go into the drawing and I'm going to start marking congruent angles in both of them. Watch. Okay, so as you can see, I've marked them up. Notice I was careful not to mark the green angles with the same marks as the blue angles because they're two different angles. They're not necessarily equal to each other. Matter of fact, after today's lesson, you'll know that for sure that they're not. So let's go ahead and just kind of think through this. I need to come up with three angles that add up to equal 360 degrees. So I have to do some calculations for the green, some calculations for the blue. Let's pull a formula that we wrote down on our formula sheet last time and use it today. Here we go. And there it is. Okay, so if you take a look at the top of this thing, that's the sum of all the interior angles of one of these polygons. And the bottom, we're just taking that sum, however big that number is, and we're going to divide it evenly to each one of the angles in these figures. And that will give us how much one of the interior angles is. Okay, so let's take a look at. Here's the work for the 8-sided interior angles. Now this is super important. We can only use this formula right here on regular polygons. Those are the shapes where all the angles are the same. So there, I've put the numbers in. I'm going to start calculating what each interior angle is for those green ones. Okay, doing super simple math. There I go. I have 135 degrees. So now I know that's 135 degrees. I'm going to simply put that up for that one angle right there. Now what I want you to do is keep my instructions there, my copy, my template. I want you to do the same now for the blue. See if you can work that one on your own. If you do that one on your own, you've got this concept. So put me on pause, and in just a minute, the work will show up. Do it on your own first, though. And hopefully you got it to be 108. So that right there belongs on that angle right there. Okay, so now we're ready to just write our equation. Don't just start waiting for me to copy it down. Put me on pause. Check yourself. Write the equation you think I'm going to write. Then, all right, and there's the equation that you should be writing to find the sum of all those angles, or write an equation so you can find an x. I see an unknown. You have to write an equation. There it is. So if you have any questions about that, you certainly can come in after school, and then while we're working in class, you could ask as well. There's a lot of thoughts there. So the more you do, the more practice you do, the more thinking on your own, the more solidify for you. If you're just simply taking notes, that's where you're going to get in trouble. Let's move on. All right, here's a new concept that we're going to be kind of adding to. We're working with exterior angles of polygons. This one comes across first like not having the right amount of information, like we need more. And so it says this. It says each exterior angle of some regular polygon measures 60 degrees. Name the polygon. In order to do this, we're going to have to calculate how many sides it is. So let's write up an equation. We learned in part 1, if you didn't do that, you lost out on some formulas. You need to go back and do them. We learned of an exterior angle equation for regular polygons. And there you have it. Basically, it was saying that the sum of all the exterior angles all day long is equal to 360 degrees. Interior angles differs by the number of sides, but the outside exterior angles always add up to 360. It doesn't matter if there's 5 sides on that figure or 105 sides. Okay, so to find what just one of those exterior angles equals on a regular polygon, we're going to take that 360 and divide it by the number of exterior angles, or the number of sides. It's a real simple process. So they gave us some of the information for this equation. They told us that each exterior angle is 60 degrees. So we just need to plug that in there and solve for the unknown n. And there you have it. 6 sides. That's what that n equals 6 means. There's 6 sides in this. Now the last question says name the polygon. So if you don't know what a 6-sided figure is, you want to go on Google right now, find out what that is, and then check yourself by putting me on pause. And there you have it, hexagon. Let's move on. I love working on the outside of these figures. It's so simple, 360. It's always going to go back to that. So taking a look at this equation, what I want to really point out, I love this about when we have equations and you memorize them. There is one component here, 1, 2, 3 pieces to this equation. And so what I want you to know is that whenever we're working with an equation, we can only have one missing piece. So this 360, this expression, this part that's considered number 3, that 360 will always be there. I don't need to find something out or whatever. The n might be unknown or the exterior angle might be unknown. But given an equation like this with 2 pieces that are unknown, I have to know one of them in order to get the other. Okay, so in this case, I knew what the exterior angle was, right? I knew what the exterior angle was, so I plugged it in there, and then I solved for the unknown sides. So what your job is to know which equation to use in which instance. What I would suggest is that you put a big, huge title in this area of your notes so that when you're dealing with a problem that has an exterior angle of a regular polygon on your problems in class tomorrow or the next class, you want to be able to go find it in your notes. All right, here's an interesting problem. Part of a shape has been covered up. We cannot tell how many sides this is. Now you could probably start guessing, how many sides it has. You're missing the point then. That's a 5th grade way of dealing with it, and it's just a guess. We want to use facts, we want to use formulas, we want to calculate this thing. So basically what it's going to come down to is this. We're dealing with the outside, the exterior angles of this figure. I know 360 degrees is what I'm dealing with. So every exterior angle is 360 or is 36 degrees in this regular polygon. If it's an irregular polygon like the problems we did last time, we don't know, they could change. One would be 36, one would be 24, it doesn't matter. But in a regular polygon, every one of them is 36. So each time I go around the corner, I throw away 36 degrees. And so there's 360 degrees here. And what I need to do is figure out how many times can I throw away 36 degrees before I run out of my 360 degrees. So 36 degrees, 360 degrees. So let's write the formula for exterior angle. So once again, I'm looking for the number of sides. So I'm just going to plug in the information I know and start solving. Fancy that. It's a 10-sided figure. And so it's asking you what type of shape is this polygon. So you have to come up with the name. So if you're not sure what a 10-sided figure is, time to go to Google again. Didn't give you much of a chance. There it is, the answer, decagon, right? So sure enough, if I remove and let you see the rest of this thing, you'll see that it's a decagon. There it is. Okay, 10 sides. Cool, on to the next. All right, here's an interesting thing. So I have partially, again, a partial shape that's not fully disclosed. To see that the interior angle is 108, and so I need to calculate how many sides and what type of polygon it is. So I'm going to take this problem and turn it into a problem that we've just done. We've been doing problems with exterior angles, and so that's what I'm going to do. I'm going to take this and turn it into an exterior angle problem. I need to realize that that exterior angle, this one out here, is a part of a linear pair with that 108. That means that that angle can be found by simply taking 180 and subtracting 108 from it, and that gives me 72 degrees. Exterior angle 72. Now it's your job to go find out how many sides, just like we did before. We're now back to a problem like we just did. So now you go do the same stuff. Put me on pause and then come back to see if you got the same work. There you have it. 5-sided. Hopefully you know what that thing is. We live in Washington, D.C., for goodness sake. You better know that a 5-sided building in Washington, D.C. is called the Pentagon. All right, let's expose it. Let's see if that's true. And certainly it is. Okay, off to the next. So I'm just going to put this up here real quick, and you can copy those things down. These are the names of different sided shapes that you have to know. And so you do whatever you need to. Pentagon, we have a building here in town. Quadrilateral, hopefully you got that one. Triangle, hopefully you got that one. A hexagon, I remember 6 has an X in it, so does hexagon. Heptagon, it's the next one after hexagon. It sounds the same. Octopus, that's a real common 8-sided animal. Nonagon, it sounds like ninagon, but it's spelled nonagon. Decagon, it's a decade, 10 years, right? There's all these clues. I want you to point you to the 11. There's actually a name for 11, but I just want you to look at this one. I'm going to call it an 11gon. And you can do this with anything. You got a 13gon, 22gon, whatever, okay? So, but for these figures down through 12, I need you to recognize the numbers and their names. 12, dodecagon, my favorite. Moving on. Let me just say that you need to write those down and have those memorized for those people who don't have those. Sometimes people need to be told the obvious. Here we go. On to the next one. All right, now we're moving into the inside of the shape. Create your title if you want someplace on your paper so you can go find this area. And basically, we're going to use another formula. There it is. The sum of all the angles inside divided by the number of angles. That tells us how much each individual angle is. I count out 8 sides, so I'll just plug that into the equation. Easy peasy. There you go. Enter the interior angle for this thing. Every one of them is 135 degrees. Here's a challenge. Can you tell me what the exterior angles are? Now, one way we could do that is we could go to the outside and say, hey, there's 360 degrees of all those x's added up, and we'll just divide that by 8. Another way of doing it is, hey, this is 135 degrees, and x and that 135 are a linear pair. That means I can just simply subtract 135 from 180 to get what x is. So it turns out, what is that, 65? No. 55? I think something's wrong. Let me just double check. Yike. I'm glad I checked. Exterior angle is equal to 45 degrees. Glad I don't teach math. Here we go. Next one. All right, so here it is. Let me cover that up. So classify the shape. So, man, what a mess, huh? So take a look. I need to add one more piece of information to it. So suppose I was given this partial of a shape. It's 144 degrees. You can tell that the angles are the same. It's a regular shape, okay? So I need to figure out how many sides that is. I'm dealing with interior angles, and I need to know what sides. So I'm going to pull out my equation, my formula that deals with those concepts, and I'll solve for the unknown. There it is. So I know what the interior angle is. So I'm just going to plug that in and start solving for those ends. Okay? So I got to start flattening this thing out and get the ends on one side. So what? So I know that some of you might be looking at that and have already been lost. It is your responsibility to come in after school Tuesday, tomorrow, or Thursday this week so that you and I can walk through that. Strip the 180 through, walking through our regular algebra, get the ends on one side, move the 360 over, I get n is equal to 10. So this is a 10-sided figure known as a decagon. All right, very good. Let's move on. Okay, so these 3 problems are all problems that you should be walking, pausing, working ahead, making sure that you understand them. And they're just your templates for doing other problems similar to it. So make sure you keep good notes on. So here I have a figure, nothing drawn for me at all. I just drew in that red shape, right? It says interior angle of a regular polygon measures 150, name the polygon. So what I do when I have this problem, when they have nothing there for me, I draw it in there for me. So I just draw something in there with some corners. I'll put 150 degrees there, 150 degrees there. And I know that this is an interior angle problem of a regular polygon. So I'm going to pull out the formula that deals with, I'm going to start loading it up with information that I already know and start solving for the stuff I don't. And that's known as dodecagon, my favorite. Okay? It's easy as that. All right, now it's your turn to start working on similar problems. And so you have 5 of them this week. You need to make sure you're doing this on a separate piece of paper than your notes, because you're going to turn this in. Put your name on it, title it Polygons, Part 2. Okay, that way when you come in, it's ready to be handed in. Furthermore, if you hold on after the brief moment I leave these 5 problems up, just after that I'm going to show you how you could do the problem number 3 I just did. Very quick, easy, much easier than using the interior angle. It's a clue, it's a secret. All right, see you at class. Okay, going back and looking at number 3, interior angle. It's a regular polygon, and that's the formula that I would use typically for this problem. But I'm here to tell you a secret. The secret is working on the outside is much simpler. You just got to get there. So watch what I do and see if you can figure it out, and then you'll have a clue to a secret that will make things much easier. I typically take interior angles of regular polygons to information on the outside and deal with it as an exterior angle problem. They're so much easier for me. You can do it both ways. You can do one way, whatever you like, okay? So if you're not sure what I did, no problem. You have the tools that I gave you before your homework problems, and you're off and running. Okay, we'll see you next class.